Hello, my name is Daraja Brown, and this is my Lab 4 video report. In this lab, I studied the motion of an object that was part of a spring mass system as it moved in an arc. The purpose of this lab was to observe and explore the connection between an object's motion and the forces and energy that are related to it. The physics principles I used were formulas for spring and gravitational forces, as well as the energy principle and the formulas for kinetic, gravitational potential, and spring potential energies. I also had to utilize the velocity and position update formulas. For this lab, I used Tracker software to analyze the experimental data obtained through the video provided, Excel to create a CSV file of the observed positions data, and WebVPython to create a computational model of the object's ideal motion compared to its actual motion. WebVPython was also used to study the change in energy throughout the model. Here are my main results. While the predicted and observed X positions started out fairly accurate but changed over time, the Y coordinates were always vastly different, and I could not figure out how to fix that. For the energy plots, the change in total energy is graphed in orange, and we can see that the orange line is not constant at 0 joules, which is what the energy principle states. For this experiment, the first step in performing the lab was to identify the system and surroundings. My system is a black rectangular object referred to as a mass throughout the experiment, as well as the spring and the earth. I identified the system this way in order to include potential energy in the energy principle. The surrounding is everything else, but there were no surrounding agents additionally acting on the system. For the experiment, I utilized the video provided in Canvas. I then used the Tracker software to obtain data about the motion of the object. I set the origin of the system at the end of the spring, calibrated distance by identifying the rest length of the spring as 0.7 meters, and I oriented the axes and coordinate system for the positive y-axis to be pointing up. Then I went frame by frame through the video to mark the object's position over time. Tracker generated a table showing me time and its corresponding x and y position coordinates. I then pasted those coordinates into Excel to create a CSV file for the future computational model. And based on the tracker data, the initial position is negative 0.119, negative 0.6340 meters, and the initial velocity was calculated, as you can see here, giving a result of 0.084, negative 0.084, 0 meters per second. After obtaining this data, I transitioned to WebVPython to create a computational model of the predicted motion of the mass. Using the start code provided, I input the initial conditions for position and velocity that I just shared, as well as the mass of 0.402 kilograms. I also input other physical properties given to us, such as the values for g, the spring constant Ks, and the rest length of L0. I then input the various force and energy formulas required and ran the code, uploading the experimental data to make comparison graphs. Again, here are the results of my experimental data and computational models comparison. The X values were relatively consistent for the first half of the time period before starting to vary. The Y values, however, were vastly different, and I was unable to determine why or how to fix it. It's possible that human error played a role in this, as I had to manually identify the center of the object in every frame of the video. The spring constant and mass values could have also been inconsistent, or the initial conditions I identified may have not been completely accurate. There are many possible reasons for this inaccuracy. Here's the plot for the various energy types and their changes in energy over time. As we can see, the orange line is the total energy, and it oscillates and is not constant at 0 joules, so energy is not conserved. So what does it mean? Here, no, the energy principle is not satisfied. As I previously stated, the energy principle dictates that the change in total energy should be 0, but the orange line in the energy plots was not 0, so energy is not conserved. The outside forces must also be acting on the system, or there was an error in my lab that must have caused this variation. And using the graphs generated by Tracker, we can see the time periods for one wave in the x coordinates is 1.619 seconds, while it's 1.524 seconds for the y coordinates. And as time continues on, the estimated periods vary more and more as their averages become farther apart from each other. So, in conclusion, my personal lab experiment was not very accurate or successful at proving the energy principle, but it does raise interesting questions about what other factors could perhaps influence the energy of the system.